Hi friends, today we are going to discuss about distribution law. This is a topic coming under Physical Pharmaceutics 1, third semester. Distribution law actually it is asking as Nernst distribution law and it is a concept coming under the solubility chapter. So Nernst distribution law is proposed by the scientist Nernst in the year 1891. That's why it's named Nernst distribution law. If you are getting the question distribution also, it is asking about the same Nernst distribution law. And this law determines the relative distribution of a component that is soluble in two liquid mixtures where the liquid either immiscible or miscible to a limited extent. So if it is a strong electrolyte, if they are asking for the derivation, we want to show it in an organic layer as well as in aqueous layer. So in an organic layer, what happens is that strong electrolyte having a tendency to become as a monomer, and in aqueous layer it get dissociated. So dissociation constant is K. So how we can find out the distribution is that Kd or dissociation is equal to monomer concentration in organic phase divided by total concentration in water raised to n, where small n is the number of molecules that will undergo dissociation. So let strong electrolyte be Ha. When come in contact with water, what happen is that acid become hydronium ion, and applying the law of mass action to this equation we will get the dissociation constant or Ka is equal to hydronium ion concentration into A minus divided by Ha, and finally we can rewrite the equation as Ha is equal to hydronium ion concentration square by K alpha. And if we substitute and rearrange the equation, we will come a constant or distribution law is equal to organic phase to the aqueous phase. That is the concentration, how much in the organic phase to that of aqueous phase. So we will get the concentration Kd by Ka. Where is it a constant? We will get C1 by C2 square. So as per the modified distribution law, we can rewrite as dissociation or distribution coefficient is equal to monomer concentration in organic phase divided by total concentration in water raised to n. So if we are telling about the derivation part, we have to show how the distribution or dissociation or distribution happen. Like one is in organic layer and in aqueous layer what happens is that dissociation happens. So as we said like that, Ha is the acid come in contact with water, hydronium ion concentration and anion will come, and finally degree of dissociation is equal to Ka plus square root of K2 alpha plus 4K alpha into W by 2. As per distribution law, distribution coefficient is equal to concentration in organic to the aqueous phase. So this distribution law help us to determine the relative distribution of a component that is soluble in two liquid mixtures, either immiscible or miscible. So this is the organic phase and this is the aqueous phase. So what happens is that as the distribution starts, the molecule from the organic phase will move to the aqueous phase. In organic phase, K is greater than 1. In that case, solute prefers in organic phase. If the distribution coefficient is less than 1, in that case what happens is that it prefers to move into the aqueous phase. So Nernst distribution law means when a solute, that is either a solid or liquid, added to a mixture of two immiscible liquid in an amount insufficient to saturate, what happens is that it will try to distribute between two solvents. So that is K is equal to organic phase concentration divided by aqueous phase, where K is the distribution constant or distribution ratio or partition coefficient. So the same thing we had done in our lab as partition coefficient experiment. So we want to show with the example. So what are the limitations of partition coefficient or our distribution law? First thing is that the distribution constant is temperature dependent. Means if we increase the temperature, solubility will increase. Second thing is that the distribution law is applied only to ideal dilute solution. In that case only we can tell about the distribution law. Third thing is that the solution should not undergo any change in its molecular state and should not react with any of the solvent. In such case, we cannot explain our distribution law. And next limitation is that partition coefficient or partition constant is not accurate determination for ionizable compound. Means in case of ionizable compound, we cannot accurately determine our K value. And we want to find out the partition solvent. So the partition solvent, commonly used partition solvent is octan 1-ol. But if octan can donate, means octan property is that it is having a resemblance to lipid bilayer. So if it is having more distribution, what happens? It will diffuse through the membrane. So we want to choose a particular partition solvent to apply this distribution law. So these are the limitations of distribution law. So what happened is that based on the limitations of distribution law, some changes, that is we are instead of concentration of organic base by aqueous base, we will modify as K into n power of square root of organic phase divided by aqueous phase, where n is the order of association. Coming to the application of distribution law, we can see wide application of distribution law. First, in the absorption of drug across the biological membrane, we can see the application of distribution law. And in the preservative action of weak acid in oil and water, example, benzoic acid, if you are using a preservative in emulsion, we can use this application. Third one, for isolation of chemical constituent, especially in the extraction of the plant drug in the industry and biological fluid, we can see this application of distribution law. And next application is the drug distribution at receptor site, that we already know about the ADME process, right? So in that cases, we can see the octanol water partition coefficient of the drug for that drug distribution. And next application is then we can see in the release of drug from the ointment base. In that case also we can see the application. Then in analytical procedure, especially in SPLC, we can see this application in the rational drug design. For example, in case of epinephrine, we can see structure activity relationship. So that structure activity relationship based on the membrane permeability, we can change or improve with the help of this distribution law. And for determination of stability constant of the complex also, we can use the concept of partition coefficient. The thing is that the method distribution can use to determine the stability constant. So this concept we are using in case of caffeine, PVP, etc. And in the complexation and partitioning ability also we can see the application. Example, in case of complexing action of the iodine by potassium iodide, in that case that partition ability we can see. So these are the various applications of distribution law. Hope this video will be useful. If you find useful, please share to your friends. Thank you for watching.